Hey, Algebra 2, let's talk about multiplying and dividing rational expressions. To start out, I want to do something really simple like multiplying fractions. Let's remind ourselves how to multiply fractions. Okay, just a simple multiplication of fractions. What I would normally tell you is it's simply multiplying across the top and multiplying across the bottom, which would give us 8 over 15. But what we really would want to do is to simplify the numerator and denominator first before multiplying, and that's what we're going to do with rational expressions today. All right, our rule. If A, B, C, and D are rational expressions with B and D not equal to 0 because they're in the denominator and they cannot be 0, then we show that we basically multiply across the top and across the bottom. Okay, let's make a conjecture about the product x cubed over 4y times y squared over x. Okay, what will it be? Explain your conjecture. Give evidence that it's correct. We're going to do it the hard way first. Let's go ahead and multiply across the top and across the bottom. We have x cubed over 4y times y squared over x. Multiply across x cubed y squared over 4xy. Okay, notice I did write x first. You certainly don't have to, but I'm just so used to writing my letters in some kind of, alphabetical order. So let's identify the greatest common factor of the numerator and the denominator. Of the numerator, it looks like I have I have an xy in the numerator, and that leaves me x squared y and an xy in the denominator. And that leaves me a 4. So the greatest common factor between the numerator and the denominator is x and y. So we can divide those out, cancel them from the top and the bottom, and reduce our fraction and get the answer x squared y over 4. Okay, we cancel xy or cancel the common factor. We're intentionally avoiding them. So divide out is what we're going to try to remember using that terminology. Divide the common factor. So we found the common factor and then we divide it. Okay? As our math gets harder, we're going to want to just avoid the word canceling because we really don't cancel everything when we simplify. So we're just going to be dividing things out, if that's all right with you. Let's try another one. So find the following product. Okay, with this case, we'd actually like to factor the numerator and the denominator of everything first. It's just going to make our lives a lot easier, and we can divide out our common factors once we're done factoring. So for that numerator, I'm going to go ahead and factor a 3 out, and I get x minus 2 left over. Denominator, I've got 2, x plus 3. Numerator over here, 5, x plus 3. And down here, 4x plus 2. I'm going to rewrite those. If you look at my homework as you're doing your problem set, you'll see I generally write above and below the numerators when I'm factoring, but it can sometimes be hard to read. So I'll go ahead and write it out again for you guys. Okay, I'm going to multiply the coefficients. I've got 15, x minus 2, x plus 3 over 8, x plus 3, x plus 2. Okay, what is my greatest common factor of the numerator and the denominator? It looks like x plus 3, which is cool. So I can divide the common factor from the numerator and the denominator and get the reduced form of the product. So that gives me 15x minus 2 over 8x plus 2 as my answer. Okay, another one. Find the following product and reduce to lowest terms. I'm going to go ahead and factor the numerator and the denominator. I have 2x plus 3 in the numerator over, factors into two binomials, x plus 3, x, I think that should be a minus 2, sorry, x minus 2, times, I have a difference of two squares, over 2x. All right, the greatest common factor between the numerator, actually let's multiply it out first. Well, yeah, we'll get to the practice. Okay, I have 2x plus 3, x plus 2, oops, x minus 2, all over 2x, x plus 3, x minus 2. Okay, let's look for the GCF. It looks like my GCF is going to be a few different things. I can factor a 2 out, and an x plus 3, and an x minus 2. Okay, so I can divide those from the numerator and the denominator in order to reduce the fraction. So if I divide that out, divide out, divide out, divide out, divide out, divide out, I'm left with x plus 2 over x as my answer. Okay, I'm going to try this one on my own, and you're going to try it on your own, and let's see if we can check our answers at the end. All right, there we go. First of all, this negative 2 right there, I merely just flipped my numerator and denominator and made it a positive 2, and then I distributed that exponent over 2 to everything in the equation. Okay, if you have any questions, star it and we can talk about it tomorrow. Okay, now we're doing division. Okay, if you remember, division of fractions is multiplication of the divisor, reciprocal of the divisor. So a over b divided by c over d is equal to a over b times d over c, with lots of things can't equal 0 now. Okay, so let's try some and see if we can make sense of it. Okay, let's change this into a multiplication problem and factor things while we're going. So that first equation, the numerator of the first rational expression is x plus 2, x minus 2 over 3x, multiply by 2x over x minus 2. Multiply it out, 2x, x plus 2, x minus 2 over 3x, x minus 2. My GCF is x minus 2. So let's divide that out from our numerator and denominator. Oh, I also have a GCF of x. Don't want to forget that one. And we're left with 2x plus 2 over 3. Excellent. Let's try a few examples or a few exercises. Okay, we have number 4 and 5. We'll do number 4 together, and then you can do number 5 on your own. All right, let's factor and see what we can come up with. The numerator there factors 2, let's see, x minus 2, x minus 3 over x plus 4. Change it to a multiplication of x, x plus 1, x plus 4 over x plus 3, x minus 3. Multiply through, x minus 2, x minus 3, x plus 1, x plus 4, all over x plus 4, x plus 3, x minus 3. What is our GCF? I see an x minus 3 and an x plus 4. So let's go ahead and divide that out. And we have our answer. X minus 2, x plus 1 over x plus 3. And notice I never re-multiply those or FOIL them. I leave them just like this. Okay, go ahead and try this one on your own. I'm going to push pause and do it on my own, and then we can meet up at the end. Okay, check out the answer and see what you think. Go ahead and push pause and look at it. Okay, in summary, we extended multiplication and division of rational numbers to multiplication and division of rational expressions. So to multiply two rational expressions, we multiply the numerators together and the denominators together and then reduce to lowest terms. To divide one rational expression by another, we multiply first the multiplicative inverse of the second and reduce to lowest terms. To simplify a complex fraction, apply the process for dividing one rational expression by another. I thought that was fun. I hope you guys enjoyed it too.